Good morning, students. So in the last class we have discussed the different types of piles, that is the classification of pile. Okay, so next is pile accessories. The main two accessories of pile are pile cap and pile shoe. Okay, pile cap, and this pile cap is provided to protect the top of the pile from blow of hammer. Okay, that is there in this figure there are number of piles. Okay, so these are piles, and for all these piles we are giving a protective structure on top of the pile, top of these piles, and this is known as pile cap. So this pile cap is provided to protect the top of the pile from blow of hammer. Okay, and this pile cap carry load from structure and distribute this load to different piles. So generally this pile cap is made of steel, and thickness and size of the cap depends upon shape and size of the pile hammer. Okay, the pile should penetrate into the cap at least 10 centimeter length. Okay, so for at least 10 centimeter length these piles should penetrate into the pile cap. For a group pile, a common RCC is provided for all the piles. So this is pile cap. So this structure are known as pile cap. Under this pile cap there is pile. Okay, next is pile shoe. Pile shoe means pile shoe is fitted at the bottom end of the pile to protect the pile and facilitate easy pile driving. So in order to enhance the pile driving process, we are providing pile shoe at the tip of the pile. Okay, so this is pile shoe, and these pile shoes are made up of cast iron, steel or wrought iron. Next topic is pile driving equipment. Okay, the operation of inserting pile into the ground is known as pile driving, and these pile driving are usually done by means of hammer. Okay, the equipment used for lifting hammer and allow it to fall on the head of the pile is known as pile driver. Okay, so using this pile driver we are lifting the hammer and we are falling this hammer on the head of pile. Okay, that equipment is pile driver. And various methods of pile driving are hammer driving, vibratory pile driver, water jetting and hammering, partial anchoring methods. So these are the various pile driving methods, and pile hammering is the most common method, and different types of hammers are used for driving the pile. Okay, and they are drop hammer, single acting hammer, double acting hammer, diesel hammer and vibratory hammer. Okay, so these are the different types of hammers. You just note these terms only. Okay, next, determination of type and length of pile. So in order to find the type and length of the pile there are so many factors. First one, type of structure and the load it carries. So based on the type of structure and the load which is carried by that structure, we are determining the type of pile and the length of pile. And also based on location of the site and soil condition and position of water table. Then this required pile length is based on soil strata and structural capability of pile. Then durability, economy. So based on these factors we are finding the type of pile and also the length of the pile. Next is selection of material, that is what type of pile we have to provide. That is in order to find the type of material for the pile, the main factor is load. So if the load on the superstructure is very less, we can adopt timber pile, but subject to decay. That is, the timber pile will be subject to decay due to alternative wetting and drying. That is one drawback of timber pile. But if the load is very low, we can provide timber pile, and if the load is heavy, we can go for steel pile, but the steel pile will be subject to corrosion due to salts. So this is the disadvantage of steel pile. And if the load is medium, we can provide concrete pile, but this concrete pile will be subjected to deterioration due to sulfate attack. So these are the drawbacks of different types of pile. So next topic is pile driving formula. That is, load carrying capacity of a pile can be calculated using two methods. First one, static formula, and second one is dynamic formula. This part is very important, so problem will be asked based on this pile driving formula. So first is static formula. So in static formula, ultimate bearing capacity of a pile is considered as the sum of end bearing and resistance of skin friction. So in the last lecture we have studied end-bearing pile and friction pile. So in the case of end-bearing pile, the load is transferred into the hard strata, and in friction pile the load is resisted by the friction which is developed between the pile and the soil surface. So in static formula, the ultimate bearing capacity Qu is considered as the sum of end-bearing Qp plus resistance of skin friction Qs. That is, Qp plus Qs is the ultimate bearing capacity as far as static formula is concerned. That is, Qu is equal to Qp plus Qs. It is the load Qu, ultimate bearing capacity. This Qu or load is transferred into the pile, and it is resisted by end bearing and also skin friction. So Qu is equal to Qp plus Qs. Okay. Qu is equal to Qp plus Qs, and Qp, that is Qp is the end bearing resistance. Qp is equal to Qp into AP. Qp is the unit end bearing resistance, and AP is the area at the base. Okay, that is, in end bearing we are transferring the load through the end of the pile, so we are considering the area at the end of the pile. Okay, so AP is the area at the base, that is Qp into AP, plus this is resistance due to skin friction Qs, and it is equal to Fs into As. Fs means unit skin friction, and As is surface area. Here, since it is transferred through the friction between pile and soil surface, we are considering this area, that is surface area. Okay, so as far as skin friction is concerned, we are considering the surface area, that is As. So As into Fs, unit skin friction, is Qs. So this is static formula. You should by heart this equation and all the terms. That is, Qu ultimate bearing capacity is equal to Qp plus Qs. End bearing resistance plus skin friction resistance. And end bearing resistance Qp is equal to end bearing unit end bearing resistance into area at the base. And skin friction resistance is equal to unit skin friction into surface area. Okay, Qp AP plus Fs into As. So this is static formula. And for cohesive soil, what is Qp? Qp is equal to Cnc into AP. That is, small letter q is equal to Cnc from Tersaghi's equation. So in the cohesive soil, first component will be there, that is Cnc. Other terms will be neglected. Or for cohesive soil, Nc is equal to Nc will be there, and other second term, third term will be 0. So this you have studied in bearing capacity formula. So Qp is equal to Cnc into AP, and for usually pile, this Nc value is taken as 9. Okay, and Qs is equal to alpha C into As. Alpha means adhesion factor alpha, and C is the cohesion or undrained shear strength. So there is a variation between Cu and alpha. So in problem, this factors will be given. Okay, so you just by heart this equation for cohesive soil. C and Q, small letter q, that is unit end bearing resistance Qp is equal to Cnc. So Cnc into AP is the end bearing resistance, and skin friction resistance is equal to alpha into C. Alpha into C is the unit skin friction, that is alpha into C into A, surface area. Okay, that is Qp and Qs for cohesive soil is like this. And for coassular soil, Qp will be equal to, for coassular soil, as far as from Tersaghi's equation, first term C is equal to 0, coassular soil. So second term Q and Q plus 0.5 gamma D and gamma is there. So this is small letter q into AP. Okay, here it is D only because it is D foundation. In the previous one, for shallow foundation, in this equation it is Q and Q plus 0.5 gamma B and gamma width. But in deep foundation, the depth is very much greater than that of width. So we are taking D in terms of B in deep foundation or in pile foundation. Okay, so Qp is equal to Q and Q plus 0.5 gamma B, gamma D and gamma into AP in case of coassular soil. Okay, and the NQ value, here the NQ value for different types of pile based on angle of friction is given, and in problem it will be given. And the skin friction resistance is equal to sigma k q tan delta into As. That is, this is unit skin friction, k q tan delta, As is the surface area, and q is the effective overburden pressure the maximum effective overburden at the pile tip should correspond to critical depth, which may be taken as 15 times the diameter of the pile shaft for phi less than 30 degree, and for and increasing to 20 times of diameter for phi greater than 40 degree, like that. Q value is the effective overburden pressure. And K is 1 to 1.5 for board pile. K value, it's a constant, and it is 1 to 1.5 for board pile, and for driven pile it is 1 to 2. Then delta means it is angular shear resistance phi. Okay, so this is the equation for coarseless soil. So this is about static formula. Okay, so this is first method of calculating load carrying capacity, that is static formula. So from static formula, ultimate bearing capacity is equal to sum of end bearing resistance plus skin friction resistance. Okay, so for finding out QP and QS for cohesive soil and coarseless soil, there are different equation. In the case of cohesive soil, this QP, that is first term QP is equal to CNC into AP, and QS is equal to alpha C into AS. Okay, and for coarseless soil, QP is equal to QNQ plus 0.5 gamma D N gamma into AP, and QS is equal to sigma K Q tan delta into AS. So in the next class we can do some problem. So when doing problem, you will be clear about this equation. Okay, thank you.